Hello everyone, welcome to another video of the course. In this video, we will discuss the object-oriented programming. Yes, so in this course, we will use the MATLAB software and the ANSYS Maxwell software for finite element calculations. So the main design workflow is in MATLAB. Okay, so we use the object oriented programming to create the motor object model, and for this object model, we can use available optimization functions in MATLAB and develop a well targeted design workflow in MATLAB, and just use the ANSYS Maxwell in the background for the finite element calculations. So when I explain the first example, it will be clear for you this process. Just bear with me and let's go through the example of the object-oriented programming step by step, and then we do the same thing for the motor design. So here in this slide, you can see the keywords that are related to the object-oriented programming. So we have classes, objects, and we have these concepts, the inheritance, encapsulation, and polymorphism. So as you know, we have two different type of programming. So this is the classical one. We have the procedural programming, that you have a main program and then you write different functions, for example, function 1, 2, 3, and in this case, function 4 uses the function 1 and function 2, and so on. So first we define the functions, and the functions should be in a proper order. So first we should define function 1 and 2, then the function 4 can use the function 1 and 2, and the main program that we have for the design or for problem solving, and so on. So what we use in this course is object-oriented programming that is much better than the procedural programming. So you can search these keywords on the web and learn more about these two type of programmings. Yes, there are lots of good videos on YouTube that you can watch about the object-oriented programming in MATLAB and so on. So I will explain why we should use the object-oriented programming. This type of the programming is much more effective for motor design. Okay, we can sort out our design variables and we can do the optimization in a more straightforward way. So I am going to explain this example, the point on XY plane. Okay, and first I am going to use the procedural programming, and then I use the object-oriented programming to explain the differences between these two type of programming. So first, let's create a new folder on desktop, example, and set the current folder of the MATLAB to the same directory, desktop. where is the example is here. So the empty folder that I have here, this is the current folder. And let's create a new script. So in this example, my object is a point on the x and y plane. So for this point, we have these two properties, x and y coordinate. So a point on the x and y plane is known by its x and y coordinate. So when we have these two properties, we can calculate other properties. For example, the r, that is the distance of the point from origin, or theta, that is the angle of the point with respect to the x-axis. So here I can write this M file. So let's save this as main clc close all clear, save. And this is one type of the programming. I can define my point. For example, here I can write x is equal to 1 and y equal to 4. So in the main M file, I can define a point by defining a variable x and y. Then I can define multiple functions. For example, this is the first function. I define this function. For example, the func1 is the distance from origin. So we know that we have two inputs, x and y, and one output, that is distance. And as you know, distance is equal to sqrt of x to the power 2 plus y to the power 2. And save this function. So here, as you can see, we have the main M file and the func1, that is distance from origin. So the icons are different. Okay, so then I can use this function here, func1 distance from origin, x and y. So this is d, and let's run the main file. Here you can see the distance of the point from the origin. So this type of the programming is shown here, the structure. So now let's calculate the angle of the point with respect to the x-axis. So here I want to calculate the angle in terms of degrees. So here I define the function 2, that is the angle. I use this function a tan 2 y and x times 180 divided by pi. So let's save, and I use this function here to calculate the angle of the point with respect to the x-axis. So this is the angle. That is equal to 75.96. So we defined our object here, and we have two functions, function 1 and function 2, and this is the main M file. Now suppose we want to define another point. Okay, so this is the point 1, and now I want to define another point, that is the point 2. So I can copy this and here write x1, y1, x2, y2, and here I can use these two functions like this. So, and for the second object, this is d2, x2, y2, and like this. So I can run. Let's change this x2 to 3 and run the code. So as you can see here, this type of programming is complex. You know, when we have multiple objects, in the motor design, when we are going to do optimizations, right? We need to investigate thousands of samples, right? For parametric designs and sensitivity analysis, right? We need to sweep over the design variables, generate different models, and analyze them, especially when we are going to use the parallel optimization, right? Parallel computations. Okay. So in this simple case, our object only has, our point object only has two variables or two properties, x and y. But in the case of motor design, we have many variables, such as the magnetic loading, electric loading, and so on, the inner stator diameter, outer stator diameter, and so on, the electrical parameters, mechanical parameters, and so on. So our object is big, is not as simple as this one. So if we want to define all of these properties for the design sample 1 and then for the design sample 2, the code will be very complex. Okay. And here, as you can see, our functions only have two arguments. But when we have higher properties, the input arguments are also higher in compared with this case. So we have one method to reduce the order of complexity. Here, for the point 1, instead of defining the properties like this, I can use the structures. Okay, so in MATLAB, we can use the structures like this. Here I can define this point and define this structure, and y that is equal to 4. So this is a structure, and this is a point structure. If I run this line of the code, evaluate selection in command window, as you can see, the type of the P is a struct. So it has two properties, the x and y. X is equal to 1, y is equal to 4. How I can access to these properties? I can write p.x, that is 1, p.y, that is 4. By dot, right? We can access these properties. Either I can change this y coordinate, for example, to 5, and here are the values. the value of the properties of the P object. So here I can define as many as properties that I need for this object. So here I define the P1 and I can define the P2 and I can modify these functions. So instead of getting the properties individually, we can get the object itself and write p.x, p.y here. Also p.x, p.y. Okay. And instead of using this list directly, I can write p1 and p2 here. So now if I run the code, you can see the calculated values. We reduced the complexity of the previous code by defining these structures, but still the code is complex. Here only I defined two functions: distance from origin and the angle of the point object. But what if I need to define other functions? So for each function, I need to generate a new file. I should select different names, right? And I should keep the order in mind, right? To use all functions in the main file in a proper order. And this is complex, and we can switch to object-oriented programming to make the code more clear, and we can do the optimization in a better way. As I explained in the beginning of this video, this type of programming is very effective for parallel computations that we need for motor design. So here I want to define a class or an object in MATLAB. So I use this keyword, the class def. I have a point class, and I will explain this keyword later. I'm going to define a handle class and end. Save. So I defined this point class. You can see the file here, and the icon is also different from the M file and the function. So we defined a handle class. You can search about this keyword in the MATLAB help, and I will explain what is a handle class later. So for each class, we have several blocks. For example, I can define the properties of the class in the properties block. So I know that the point class has two properties, the x and y. So in the main file, if I define a point like this, P, I want to generate an instance of the point object. So if I run the code, as you can see, the P is a point object with two properties, x and y. But these properties are empty. We can set these properties like this, p dot x equal to 1. But also we can initialize the value of the properties directly here when we define this point object, when we generate an instance of this point object. So I can define multiple instances of this object, for example, P1, P2, and P3. Okay, so here you can see the P1, P2, P3, P2.x. I can modify it, right? So this is P1, this is P2, and as you can see here, I can handle different samples of the same object in a more easier way. For example, we have the sample design 1, sample design 2, sample design 3 for our motor, right? For example, by changing the value of the inner stator diameter, we can generate different samples of the design. So here just we have a structure, right? This class is like a structure. Just we defined these two properties. But if I want to use the class concept in a better way, I should use the method block and define the functions that are related to the class object. So I have these two functions. So let me copy this and paste it here. Okay. We define the methods related to the class inside the methods block. You know, everything in MATLAB is an object. For example, this number a equal to 5. So what is the class of a? This is a double type. And what are methods of a? We have these functions. These functions are methods of a. You know, for example, if I write a, the floor of a, this is a function, right, defined for this double object. And here we define this function for this object. And you know, the first input, the first input of the functions in the methods block is the object itself. Okay, so this is the first input of each function for the point class. And the obj is a pointer that points to the object itself. You know, here I write obj.x and obj.y. So, you know, simply we can call this function like this. If I write p1 dot, I have access to this function. I can write like this. Here you can see the calculated distance from origin, or I can write like this, P1. Okay, we know that the first input of the methods, right, of a class of an object is the object itself. So we can write P1 dot function distance from origin, or we can calculate the distance from origin by this syntax. And let me delete this, save, and also define the second function for the point object, that is its angle. So this is the pointer to the object, and let's delete this. Now let's delete these two functions, and as you can see, only I have a main M file that is for my design for developing the optimization workflow. Okay, and this is the point object or the motor object that I will define it later. And as you can see, the code is much more clear. The point object has two properties, x and y. And if I need other properties, I can call the functions like this: p dot distance from origin, p dot angle. And I can generate multiple samples, right? Like this. So, yes, this is the difference between the procedural programming and the object-oriented programming. I tried to present this simple example. You can write this code and try, and also search on the MATLAB help for these keywords. Anyway, in this course, we will use this design workflow. So here you can see the MATLAB environment. We have an object, right? A motor object that is developed in MATLAB. And for this motor object, we can write several methods, right? Like this one, distance from origin, angle. But in the case of motor design, for example, one method could be this: run magnetic loading calculation or anything else. And we have these methods, we set parameters, do finite element analysis. So when we are going to do the finite element analysis, we run the FEA software. That in this course we use the ANSYS Maxwell in background and return results. Then we modify the design, run sizing, modify, right? The optimization process is in MATLAB. The main design workflow is in MATLAB, and just use the ANSYS Maxwell in background for the finite element calculations. So, anyway, I think it's enough for this video, and you can try this point example yourself. In the next video, we will generate the geometry of the stator core in MATLAB, and we will develop the motor object. Okay, and then after completion of the geometry creation, we start the analytic design of the motor. Thanks for watching.